Today we're going to look at section 5.5, and we are going to be using properties of parallelograms in proofs. So let's review the 5 properties of parallelograms. Remember, when you have a parallelogram, opposite sides are parallel. Opposite sides are also going to be congruent. Opposite angles are congruent. Consecutive angles are supplementary. Remember, consecutive means right next to each other. So either like the 2 down at the bottom are consecutive, or the 2 to the side are consecutive. And then diagonals bisect each other. So those are the 5 properties of parallelograms. So anytime you are given a parallelogram, we can then conclude any of these 5 things. Okay, so let's take a look at this proof. We're going to number our steps just like we always do. Whoops. So step number 1, remember that symbol means parallelogram. So we are given the parallelogram WXYZ. Remember, when you're given a parallelogram, you have 5 different properties. But right off the bat, if I look at this picture, notice that I don't see any diagonals. Because if you remember, to be a diagonal means that it goes from one vertex to the opposite. It goes from one vertex to the opposite. That's what a diagonal looks like. That's not what I'm seeing in this picture. And I'm probably not going to want to draw in any diagonals. So that property we don't need to really be thinking about. Notice at the end, we're trying to prove that we have congruent triangles. We want to try to prove that the triangle of UWX, which is this triangle up here, is congruent to the triangle of VYZ, which is this triangle down here. So because we're trying to prove congruent triangles, that means that we want to get pieces to be congruent. And so we probably then also are not going to use that property that consecutive angles are supplementary. Being supplementary isn't really going to help me necessarily get congruent triangles. So right off the bat, I've eliminated 2 out of the 5 choices. So what from a parallelogram is going to help me with these triangles? Well, notice that we actually highlighted a couple of sides of the parallelogram and their sides of the triangles. Notice that one of them is the side WX. Notice that it is opposite the side of YZ. And remember, we can say that those are congruent because if we have a parallelogram, we get to start there. Then we know that opposite sides are congruent. Okay, so when we have a parallelogram, opposite sides are congruent. I'm going to give each of those 1 tick mark. There is technically something else from this big parallelogram that will also be inside those 2 triangles I want to prove congruent. I don't know if you can see it, but notice that angle W is in that parallelogram. It's also in that top triangle. Notice that angle Y is in that bottom triangle. It's in that parallelogram. Notice those are opposite angles. So I get to say that they're congruent because once again, when you have a parallelogram, opposite angles are congruent. So then I can mark those angles congruent. Once again, I don't see any diagonals. I don't have the full sides on the other part of the parallelogram, so I probably don't want to say anything about WZ and YX. So notice that that might be it as far as the first given. Now, if we notice that we keep going down the list with our givens and then we still have run out of things that we haven't quite gotten to our conclusion, we can go back and see if there's anything else with the parallelogram. But I am going to move on. My 4th step, I'm going to make that last given that the segment UW is congruent to the segment VY because that was given. If I mark that in my picture, UW, I'm going to give it 2 tick marks. VY, notice that gets 2 tick marks. And so then notice that the 2 triangles that I highlighted that I want to prove congruent have 3 things that are marked. So if we notice the markings, we do have enough information to go to what we're trying to prove. We can say that the triangle UWX is congruent to the triangle VYZ, and that's because of side, angle, side. Notice that our first set of congruent sides came from step number 2. Our congruent angles came from step number 3. Our other set of congruent sides came from step number 4. So we're done. Okay, notice that we are given a parallelogram ABCD. That is given. That's the only thing that's given. And once again, that means that's something we get to expand on. Okay, notice that we're trying to prove triangles congruent. So I'm going to highlight the 2 triangles I want to focus on. I want to focus on the triangle of AED, and I'm going to do a different color. And I want the triangle of CEB. So these are the 2 triangles I want to try to prove congruent. Okay, so notice that when I have a parallelogram, I've got 5 different properties. So there's actually several different ways for us to prove that these 2 triangles are congruent. Okay, notice that in the picture, they do have a bunch of angles numbered. So let's maybe focus on that for a second. Okay, if I look, remember, one thing that we know about a parallelogram is that opposite sides are parallel. And remember, if I want to try to do something with angles, if I have parallel lines, I can have relationships of angles. So I'm going to go ahead and say that the segment of AD is parallel to the segment of BC. And that's because if I have a parallelogram, then opposite sides are parallel. Okay, notice that we have several different transversals in this picture. So I'm going to highlight with my parallel side. Let's use this transversal of DB. And now this other side we just said was parallel. Notice that what I just created was the letter Z. And so when you have the letter Z, remember that means you have alternate interior angles. So the numbers that fall within that Z are angles 1 and angles 2. And remember, when we have parallel lines, so this is our reason why they're congruent. When we have parallel lines, that means that we have alternate interior angles that are congruent. So angle 1 and angle 2, those are alternate interior angles. So I can go ahead and say that they're congruent. Okay, notice that if I switch focus and I use the other transversal, because we do have 2 transversals, notice that we have the transversal of AC. Notice that what I just highlighted was another letter Z. It was just a backward Z. So we do have another set of alternate interior angles. Notice that angle 3 and angle 4 create that backward Z. So we can say that angle 3 is congruent to angle 4, and it's the same reason as 3. So same as 3. When you have parallel lines, alternate interior angles are congruent. So I'm going to mark them differently, but these 2 angles are congruent. Now we have 2 sets of angles congruent in the triangles. I need one more thing to be congruent in order for me to say that I have congruent triangles. So I can say, notice that AD and BC, those 2 sides are opposite each other. And remember, when I have a parallelogram, opposite sides are congruent. So AD is congruent to CB because once again, when I have a parallelogram, opposite sides are congruent. So there's lots of things that are marked, but hopefully you kind of noticed that we do have 3 things within each of those triangles that I highlighted. So our 6th and final step, we can say that the triangle AED is congruent to the triangle CEB. From our markings, that's because of angle, side, angle. First set of congruent angles came from step number 3. Our congruent sides came from step number 5. Our other set of congruent angles came from 4. Like I said, this is actually just one of many different ways for you to prove those two triangles congruent, because we could have used a lot of different properties of our parallelograms. Okay, let's look at this one. So I'm given parallelogram ABCD. So notice that there's a lot of stuff going on in this picture, but it is that really big four-sided shape. Okay, we do have a bunch of other givens as well. This time we're not trying to prove congruent triangles, we're trying to prove sides congruent, but there are triangles in this picture. So we're going to want to get triangles congruent so we can then say sides. Because there's so many different things with parallelograms, I think I'm going to write down my other two givens first, mark those up, and then we can kind of decide what triangles we want to focus on and what properties of the parallelogram is going to help us get there. So let's write our next given, that the angle GHA is congruent to FEC. That's given. I'm going to mark it in my picture. GHA is this little angle. FEC is this little angle. Okay, so those two are congruent. I'm also going to say that the segment of HB is congruent to the segment of DE, because that's given. HB is this side, DE is this side. Okay, so we've got everything. Notice that if I want to try to prove that the side of GH is congruent to FE, hopefully we notice we might want to use these two triangles. So let's try to prove these two triangles congruent. We already happen to have one thing that's marked in them. So remember, we just need to get two more things, and then we have enough to prove the triangles congruent to get us closer to what we actually want to prove. Okay, so going back to our first given, we can expand on a parallelogram. Once again, one important one that we use quite a bit is that opposite sides are congruent. So which set of opposite sides are probably going to help us? Well, probably the side of DC and BA. So let's say that the segment DC is congruent to the segment of BA, because when you have a parallelogram, remember, opposite sides are congruent. Okay, so then I can mark those congruent. Why is that helping me if I have triangles I want to prove and those sides are not a part of the triangles? Well, it kind of goes back to that third given with the segments that we marked in the picture. HB and ED are also not a part of the triangles I want to prove congruent. However, they're a part of the two big sides that I just said were congruent. CE and AH are a part of those big sides. So if I could start with something big and I want to prove something small, I can do that through subtraction. So my fifth step is that the segment of CE is congruent to the segment of AH, and that's because of the subtraction property. So I'm going to justify it again. Notice that my big side, let's start with the top, is the segment DC. I'm going to subtract away the segment of DE. Notice that that leaves you with the side of CE. Down at the bottom, we have the big side of BA. Notice that we have then the side that's a part of that, BH. I want to subtract that little piece away from the big piece. Notice that gives me AH. So now I have two things that are congruent in those triangles. Okay. Notice that there is one diagonal in this picture. Well, notice that if I have these opposite sides and I've got a diagonal, that means that that diagonal is my transversal. And so if you look at what I just highlighted in green, I formed the letter Z. So in order to then do something with that letter, let's first talk about those two sides besides the transversal. Notice that DC and AB are opposite sides. And remember, in a parallelogram, opposite sides are parallel. So let's say that the side DC, is parallel to the side of AB. And once again, that's because when you have a parallelogram, then opposite sides are parallel. So these sides are never going to intersect. Okay, but notice that by forming that letter Z, we have now alternate interior angles. And as long as I had parallel lines, alternate interior angles are congruent. So we have to use three letters because there are multiple angle C's. So let's say that the angle DCA is congruent to the angle of BAC, because when we have parallel lines, then we know that alternate interior angles are congruent. So now I have three things marked in those triangles that I highlighted. So we have enough to prove the triangle's congruent. So the triangle of ECF is congruent to the triangle of HAG because of angle, side, angle. My first set of congruent angles, that came from step number 2 that was given to us. My congruent sides, there's a whole bunch of them, but notice the side that we marked within the highlighted triangles came from step number 5 when we did our subtraction. Step number 7 got us our other set of congruent angles. And so remember, when you have congruent triangles, any other parts are congruent. So we can say that the segment GH is congruent to the segment of FE, and that's because of CPCTC. Corresponding parts of congruent triangles are congruent. So that's us using properties of parallelograms in proofs.